Now we're going to do question 7. We are given a graph of f of x being equals to x plus 4 close brackets open bracket x minus 6, right? The parabola cuts the x-axis at point B and D, and the y-axis at G. C is the turning point of F. Line AE has an angle of inclination of theta and cuts the x-axis and y-axis at A and E respectively. T is a point on F between B and G. So let's see all the points that indicated in the statement. So as you can see, this is the inclination angle and this is the line of AE. And then this is the T right here, and then this is the turning point, and this is the intercept of B and intercept of D, the x-intercept, by the way. So let's look at the questions. So question 7.1 says that we must write down the coordinates of B and D. So for us to write down the coordinates of B and D, remember the equation is equals to open bracket x plus 4 and x minus 6, right? So we have f of x equals to x plus 4. Let me close this nicely. Plus 4 and x minus 6. So if we find the x-intercept and y is equals to 0 here of x plus 4 and x minus 6, we're going to get x equals to minus 4 or x equals to 6. So because x is negative, so here we have negative x values and here it's positive x values, meaning that B is going to give us negative 4 and 0. Coordinates of B and coordinates of D would be 6 and 0. So that's how we find the coordinates of B and D. Okay, fine. 7.2 says that we must write down the coordinates of C. Coordinates of C, the turning point, right? What you can do is you have f of x being equals to x plus 4 and x minus 6, right? You can find the product of this, or you can simply use your intercept of x equals to minus 4 and 6, which is what I'm going to do. I'm going to say x equals to minus 4 plus 6. So this minus 4 here, I'm going to add it with this one and then divide by 2 to find this axis of symmetry. Remember, it's an axis of symmetry dividing the function into two equal parts. So it's definitely the average of the two. So just finding the average of the two, you're gonna get 1, right? Because minus 4 plus 6 gives you 2, and then 2 divided by 2 is 1. So x would be 1, and then to find the y value of the turning point, so this is the x value of the turning point, the y value of the turning point, you can use your equation here where you just put 1 when you see x, 1 plus 4 and 1 minus 6, and the answer that you need to get is minus 25. So meaning that our turning point C has an x value of 1 and a y value of minus 25, like that. So that's how we solve this question here. And then going to 7.3 says that we must write down the range of the function. So the range basically talks about the movement of the y values. So the movement of y values, if we check, this is the positive y axis, right? And we're looking at the movement of the y values for the graph of f. The y values come from this direction, right? And they're going in that direction, right? So where they come from a positive infinity. We don't know the specific value where they come from. They go down to the minimum value of minus 25, and then they go up to positive infinity, right? So someone who wants to write the range, you can write the range like this. from positive infinity to minus 25 inclusive, and 25, sorry, from minus 25 to positive infinity. So what I'm saying is, from this direction of positive infinity going down towards the minimum point of 25, right, and then starting from that minimum point of minus 25 to positive infinity, right? So that's how you write the range, or you can simply just use the turning point and say y should be greater or equals to minus 25. So either of the two should be correct. Okay, so let me erase this. So now going to 7.4, we are given an angle of theta being equals to 14.04. So that is the angle of inclination, right, here. So you're given this angle to be 14.04 degrees, right? And then the tangent f at t is perpendicular to AE. So what they're saying is there's a tangent here. I'm just going to indicate with this blue line. So there's a tangent here at t. So it's moving like this. This tangent moving like this, and then it is perpendicular to this line of AE, right? So this tangent touches point T just here. Cool. So this tangent, so let me just indicate that this is a tangent and it's perpendicular to AE, right? So then 7.1, we are asked to calculate the gradient of AE equal to 2 decimal places. So this is the line of AE, right? And we're having an angle of inclination of 14.04 degrees, right? So to find the gradient of AE, we know very well that the gradient is equal to tan of theta, and theta in this case is 14.04. So you punch your calculator, you say tan of 14.04 degrees. Don't need to put degrees, just write 14.04, tan of 14.04, and then you should get a value of let me check my calculator. You should get a value of 0.25 correct to 2 decimal places, right? So it's 0.25, which is 1/4 basically, right? So that is your gradient of AE, right? Cool. So now we know the gradient of AE. Let me just erase the top. Gradient of AE is 1/4 or 0.25. Fine. So 7.4.2, calculate the coordinates of T. Remember that T lies here at this point here. So we want to identify the coordinates of T. So for us to determine that, we need to remember that this line of tangent is perpendicular to M of AE, like it's perpendicular to the line of AE, sorry. So what that means is M of T, the gradient of M of T multiplied by the gradient of AE must give you -1, right? And so M of T multiplied by the gradient of AE, which we found to be 1/4, right? This one here, 1/4 equals to -1. So you're going to divide by 1/4 both sides, 1/4 both sides. So M of T should give you remember, okay, this is my bad. Yes, it's 1/4. No, everything is correct. So you're gonna get -4. Yes, gonna get -4 as your gradient for M of T. And then because we are looking for the coordinates of T, right? So for us to find the coordinates of T, and we know very well that T lies on the lies on the function of f, right? So T lies on the function of f. We know now that the gradient of T is equals to -4, and we know that it lies on this function of f. So the function of f is given as x plus 4, x minus 6, right? To find the product, f of x is equals to x squared minus 6x plus 4x minus 24, and then f of x is equals to x squared minus 2x minus 24. So this is the product of f of x, right? So having the product of f of x, let me write it nicely here. We have f of x being equals to x squared minus 2x minus 24, right? And we're going to derive this. When you derive this, find the derivative, you get 2x minus 2, but f prime x is equals to negative 4. So this negative 4 is the gradient of the tangent, so we're just going to equate both. So it's minus 4x is equals to 2x minus 2, and then we transpose the positive 2 to the other side. We have minus 4x minus 2x equals to minus 2, minus 6x is equals to minus 2, and then just gonna divide by 2 both sides, right? Yes, made a mistake here. I'm supposed to write minus 4, right? So minus 4 is equals to 2x minus 2. Transpose the minus 2 to the other side. We have minus 4 plus 2 equals to 2x, and then this is going to give you minus 2 equals to 2x. Divide by 2 both sides, x is equals to minus 1, right? So this is the x value of t, right? So to find the y value, just going to substitute into the original equation. So what we will do is this: we'll say f of x of t, which is equals to negative 1. Let me just write it properly. So it's equals to negative 1, like that. So we're just going to say f of xt equals negative 1, substitute negative 1, minus 2 into negative 1, minus 24, right? So the value of y, you're going to get minus 21. So basically the coordinates of t is minus 1 and minus 21, right? So let's just erase everything here and indicate that on the graph, right? So just gonna write on t the coordinates of t minus 1 minus 21. Cool. So we are done for this question. Let's look at the other one. 7.5. 7.5 says that a straight line G parallel to AE. So a straight line G is parallel to AE. So we know very well that a straight line G, the gradient will be equals to the gradient of AE, since they are parallel. Parallel lines have equal gradients. Always know the properties of parallel lines. So what's the gradient of AE? Remember, we calculated previously to be 1 over 4. So m of AE is equals to 1 over 4, right? So it's going to be 1 over 4. So now we know the gradient of the straight line, and we are told that it cuts f at k is equals to, or k into minus 3 minus 9. So this is the point where this graph of G cuts the graph of f, right? So honestly, there's nothing shown on the graph, so which means it's happening somewhere just outside of, you know, what is shown on the graph, because the point k is minus 3 and minus k, which can possibly be somewhere, let me show you, somewhere around here. So it can, minus 2 can be somewhere here, and then something like this. but yes, I might not be accurate, but it's just somewhere in this region. So what's happening is we now have our point K, right? So our equation would be y is equals to y of g is equals to mx plus c, right? And we know the gradient is 1 over 4, so it's equals to 1 over 4 x plus c. So to find the equation of g, we're going to substitute this point of k, right? Minus 3 minus 9. So where there's y, you're going to put minus 9, where there's x, you put minus 3. So it's going to be minus 9 is equals to 1 over 4 into minus 3 plus c. And then you transpose this to the other side. We have minus 9 plus 3 over 4 is equals to c. So therefore c would be equals to, please punch it through your calculator and confirm, but I'm getting minus 33 over 4. So that is the value of c. So our equation of this line of g is going to be 1 over 4x minus 33 over 4, right? So that is the straight line, but we're not done. The question says something here. So now it tells us that this line of g is going to cut the graph of f at k and at r, you see. So we don't know where r is. There's no r in the graph. It's not really indicated, but it's going to cut at 2 points, basically. That's what it's saying. So calculate the coordinate, the x coordinate of r, right? So if it's gonna cut at 2 points, and we are told that this graph, this straight line of g, it touches the graph of, or it cuts the graph of f at these 2 points, which means the graph of g is equals to the graph of f, right? So you can simply say the graph of f of x is equals to the graph of g, right? They're both equal. Then you can use let's just do this on the other side. So the graph of f is going to be equals to the graph of g, right? And what is the graph of g? The graph of g is y of g is equals to 1 over 4 x minus 33, right? So it's going to be 1 over 4 x minus 33 over 4. Cool. So having that, and we know the graph of f, right? F of x is equals to x squared minus 2x minus 24. So we're just going to equate both here. So meaning that the graph of f, right, x squared minus 2x minus 24 is equals to the graph of g, 1 over 4x minus 33 over 4. Then we transpose everything to the other side. We have x squared minus 2x minus 24 minus 1 over 4x plus 33 over 4 is equals to 0. And then we collect the like terms, so it's going to be x squared minus 2x minus 1 over 4x minus 24 plus 33 over 4 equals to 0. So if you write the standard form, it's going to be x squared minus 9 over 4x minus 63 over 4 equals to 0. So you can use your quadratic pattern, or you can multiply out the 4 and factorize. So it's up to you. I will use the quadratic formula. B squared minus 4ac divided by 2a, of which our a value is equals to 1. Let me write the 1. Our b, not d, our b value is equals to minus 9 over 4, and our c value is equals to minus 63 over 4. Right, so substitute that into the formula of x equals to minus, our b is minus 9 over 4, plus or minus the root of minus 9 over 4 squared minus 4. Our a is 1, our c is minus 63 over 4. Right, and we divide by 2 into 1. So the x values that you're supposed to get is x being equals to 21 over 4 4x is equals to minus 3. Remember, I'm getting x equals to minus 3, and I want you to see something here. That this proves that the function does touch the point k, because x is minus 3 and we just found x equals to minus 3. But we're not looking for that, we're looking for the x value of r. So meaning this is not going to be the answer because it's the x value of k, right? So the x value of r is equals to 21 over 4. So that is our final answer for this problem here. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comment section below. Don't forget to subscribe to the channel for more videos.